Hello, in this video I'm going to be going over electron configuration. We'll be starting with some basic examples. We have right electron configuration for chlorine. So the first one is chlorine, and we need to use the Aufbau Principle. The Aufbau Principle, it's German for building up, means that we need to start with the lowest energy level before we can get into the higher ones and the higher ones. So what that means is we're going to start with the configuration of simpler elements, simplest being hydrogen. We're going to need a periodic table for that. Here we have hydrogen is right here. This is in the first row or period, and it's in the S section. So remember, the first two columns are represented by the S orbital. You have columns 13 through 18, all of these guys are considered the p orbital. And then the ones in between, these, scandium through zinc, and everything below, those are the d orbital. And then going way down to the F, those are for the advanced questions. You have the F orbital. Alright, so we want to find chlorine, which is right here, number 17. But according to Aufbau Principle, we have to start at the first floor before we can build the fourth floor. Alright, so hydrogen, first row, S section. So we're going to call that 1S, 1, and then we go to helium, 1s2. Helium is an exception, it's in the P section, but it's lumped in with the S's. So it's 1s1, 2. So we're going to write down 1s2, but we have 17 electrons in this guy. We only have 2 represented, so we need to continue on to represent the rest of the electrons. So we go on to the third one, which is in the second row, and it's in the S orbital, so we're going to write it 2s, 1, 2, and it's filled up. So we have to remember that the S orbital can have no more than 2 electrons, p orbital no more than 6 electrons, the d orbital no more than 10, and F no more than 14. So those are important to memorize. And each orbital has suborbitals. So we have S has 1 suborbital, P has 3 suborbitals, and D has 5 suborbitals, whereas F has 7. And each suborbital can have no more than 2 electrons. Alright, so we have 2s2 right here, 1s2, 2s2. Computer's a little slow, so we'll refrain from switching too many times. So now we're at boron. It's in the second row, and it's in the P section. So we're going to write 2p, 1, 2, 3, 4, 5, 6. I can't have more than 6 electrons in my p orbital, and I haven't gotten to chlorine yet. So now we go to 11, but it just says in 1, 2, 3, and it's in the S section. So we're going to write 3s, 1, 2, I filled it up and haven't gotten to chlorine yet. Moving on, here I'm in the third row still, and I'm in the P section, so I'm writing down 3p, 1, 2, 3, 4, 5, and I stop. 1, 2, 3, 4, 5. And I got to chlorine. So my electron configuration is 1s2, 2s2, 2p6, 3s2, 3p5, and I'm done. So Se, and selenium is right over here, so that means we have to again do the Aufbau Principle and start with hydrogen. So hydrogen is in the first row, so I'm going to write 1, it's in the S section, so S, 1s1, 2, and it's filled up. So I keep on going, I haven't hit selenium yet. I'm at lithium in the second row, it's in the S section, 2s, 1, 2. So I write 2s2, and then I continue on to boron. And this is still in the second row, so I'm going to write 2, but now it's in the P section, 2s, or 2p, 1, 2, 3, 4, 5, 6, and it's filled up. Keep on going because I haven't hit selenium. I'm in the third row here. It's in the S section, 1, 2, S fills up, and I continue on still in the third row, but now I'm in the P section, so it's 3p, 1, 2, 3, 4, 5, 6. Moving on to the fourth row in the S section, that's 4s, 2, 1, 2, and this is where it gets a little bit different. I'm not in the S, not in the P, I'm in the D section. It's in the fourth row, but I have to remember that D is one less than the row it's in. Why is this? Because D can have a max of 10 electrons, where P has a max of 6, S has a max of 2. And that attraction of those electrons towards the nucleus, because you have so many of them, is greater, that orbital is going to move closer to the nucleus because you have that stronger attraction because you have so many more electrons. So this is going to be, instead of 4D, it's going to be called 3D. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Totally filled up. 10 is the max amount D can have. And we continue on. We're still in the fourth row, and it's the P section, so we will call it P. It's 4p, 1, 2, 3, 4. And that's the electron configuration for selenium. A little more in depth because you have that d orbital happening. Alright, I just want to recap. Just so we know, we've got S orbital has a max of 2 electrons, P orbital max of 6, D orbital max of 10, and F orbital max of 14. So that's key to know when we're doing our electron configuration, because then we can know when we need to stop. Because you're never going to see 2s3. Max would be 2s2 or 1s2. Alright, why don't we do silicon? Silicon is right here, but if we're doing the Aufbau principle, we got to start at the beginning, which is hydrogen. It's in the first row. It's in the S section. We have 1s, 1, 2, and it's filled up. We keep on going. Second row, S section. That's 2s, 1, 2. And now we're in the P section, still in the second row. So it's 2p, 1, 2, 3, 4, 5, 6, and it's filled up. Keep on going because we haven't hit silicon. Third row, S section, 3s, 1, 2. And now we're in the 3p section, 3p, 1, 2. And that is silicon. Alright, doing the next one real quick. We have potassium. This tricky guy. It's right over here. So we have to do Aufbau principle. Start at the lowest energy level. First row, S section, 1s1, 2. Keep on going. 2s1, 2. 2p, 1, 2, 3, 4, 5, 6. And we have 3s1, 2. And then 3p, 1, 2, 3, 4, 5, 6. Looks like we're coming to our last one, potassium, 4s1. And that's the electron configuration for potassium. Alright, and let's do the last one, magnesium. So magnesium is right over here. We have to start at hydrogen. It's 1s1, 2. 1s2. Here we have 2s1, 2. We go to number 5, 2p, 1, 2, 3, 4, 5, 6. And then we have 3s1, 2. And that's the electron configuration for magnesium. Alright, I want to do one last thing, and that's counting how many valence electrons we have. So valence electrons are outer electrons. They're the electrons that are involved in bonding in chemical reactions. So we have in chlorine, first energy level. Here we have the second energy level, which includes 2s2, 2p6. And here we have the third energy level, which is 3s2 and 3p5. Our outermost energy level would be the third energy level. That's the highest out. And we not only have the 3s2, but it's the 3p5. So we add all of those electrons, the 5 and the 2, which gives us 7 valence electrons. VE stands for valence electrons. Looking at scandium, we have the first, second, third, fourth energy level. The fourth energy level in this case is the furthest one out. We have 4p4, 4s2, 4 plus 2 is 6. We have 6 valence electrons. Silicon, right over here, first energy level, second, and then the third is 3s2 and the 3p2. Gives us 2 plus 2 is 4 valence electrons. Alright, potassium, 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. We have 1 valence electron, that 4s1. Alright, here, 1s2, 2s2, 2p6, 3s2, furthest one out is that 3s2 orbital, which has 2 electrons. So we have 2 outer electrons. So that's pretty much how you find how many valence electrons or outermost electrons there are in an element or a particular atom.